Hey guys, welcome back to Python. In this lecture, we're going to finish, I swear this time, our creating functions series of videos. We are getting down there. We just made help files for our last video, so if you give your code to another individual that wants to understand what you're doing and how to actually use the functions you've written, they can type help in the name of the function, and then whatever you've written as a help file is in there. And so now we're going to define the defaults. So sometimes you see people in papers, they're like, oh, we use this package with the default settings. You can define it so if there's a setting that is going to work for 90% of analyses, or a large portion of analyses, the person's not going to have to change their p-value, for example. 95% of people use 0.05. Well, we can set it where the default is 0.05, and then if it's not put into, like if it's not brought up in the coding, then it just defaults to 0.05. But you can specify to change it, but that's only if the user wants to. It's a lot of functions, people just use the default settings. Okay, so without rambling too much more, let's jump on in. All right. So let's do this numpy load txt inflammation .csv, and then we're going to do delimiter equals commas, since it's a CSV, comma separated. Okay, so what's different about this? I haven't run it yet, but previously, when we've loaded these things, if I go up to my previous code, oh, by the way, I'm just continuing on from our last code of the help files. But we did, how far back did we do that? We specified file name, right? So here, fname equals file name. But we can make it so our function, you don't have to call fname. But you do still have to call the delimiter, right? So if we run this, we still have the same thing as before, but we no longer need to do the fname because of our defaults. But if you look at, if we did this, so I'm gonna copy and just paste this. If we get rid of delimiter and we run it, we have an error, right? Because it's like, okay, I don't know why you did that. What does the comma mean? So to understand what's going on, let's redefine our offset mean function that we've been doing. So we do def offset mean. Actually, I'm just going to copy this. So this is the one we're going to copy right here, right? So Control C, right clicking, I don't know if it, just Control C. Control C, I'm going to bring it down here and hit Control V. And so what we have here, what we're going to change, our target mean value equals 0.0. And then we're going to say return a new conditioning to the original data with its mean offset to match the desired value. And we're going to do comma. We're going to say 0 by default. And then examples, we're going to keep the same. Offset mean, I'm going to make that lowercase because it was supposed to be before. Offset mean 1, 2, 3. And I'm going to get rid of this. And then array -1, 0, blah, 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 blah. And okay, now I'm going to run this. So the key change is that the second parameter is now written as this target mean equals 0.0, and instead of just target mean value. So if we call the function now, test data equals numpy zeros to 2. Oh, I need another, oh no, to 2, like that. And then we say print offset mean test data 3. What happens is you can see that we have this same matrix that we had before, but now what we can call it with just one parameter, in which case target mean value is automatically assigned to 0, right? So we had our data, and then we have our target mean value, which is 3, right? So we can do print offset mean, and then we can say test data. That looks right. And you can see that since our target mean value was set to 0, it just automatically puts 0 in for us. Okay, so let's do so as like software carpentry people say, so this is really handy if we usually want a function to work one way, but occasionally we need it to do something else or change a specific parameter. We can allow people to pass the parameter when they need to, but provide a default that makes the normal case easier, right? So some of these functions, what's a good one? So if we do matplotlib python. So if we look at, let's look up matplotlib example user guide. How to. Where's all the matplotlib? Let's do actually dseek. So this is, I'm just going to pull up the R one because I know that it's going to have, so it shows the arguments, right? Same thing for Python, but I know that this is printed nicely to exemplify my point. So these are all the arguments, right? So if you're doing DESeek, which is a program that lets you identify differentially expressed genes across conditions, to run it, you have an object, a test, a file type, a prior beta or beta prior, a full, a reduced, a quiet, all these different things. And this is a short one. Some of these functions have like 50 different variables that you can change to like modify its work. Well, if every time you ran this, you never had to change this thing, but you had to type it in, it'd be a pain in the butt. So most of these things, if you look at the top, they show, or on this one, examples. So DESeek, DDS. So all you have to do is call DESeek and then give it the data frame, because everything else has a set default, right? And so that really saves you having to change things or type them out if you're never gonna, if it's not valuable to you. Okay, let's see. What else do you want to talk about here? Let's do okay. So let's do this. Make sure I'm still on my same file. Let's define display a equals 1, b equals 2, c equals 3, and then we're going to do print a. So we're saying print, show what a is, like print this literally, and then print whatever is stored in the value a. B, going to say print, no parameters. Then we're going to say display. We're going to say print one parameter. Okay. That's not what I want to do. And I'm going to say display 55. One of these days I'll get it right. Print two parameters. And then we're going to display 5566. All right, let's run this. Okay, so as this example shows, parameters are matched up from the left to the right, and any that haven't been given a value explicitly get their value, their default values. So you can override this behavior by naming the values as we pass them in. So what it's saying is, you can say we have our values up there. So it says, okay, by default, A is 1, B is 2, C is 3. So if you give it one parameter, we still get B is 2 and C is 3. If we give it two parameters, we still get C is 3. So let's do this. Print only setting the value of C. And so if we say display C equals 77, and we run it, you can see that we had a default, right? So default A equals 1 and B equals 2. So when we only give it C equals 77, it's just going to use those default values for A and B. So let's try help numpy load text. Oops. So the most important part, you can see there's a lot of information. So this was probably a better way than pulling in RCode. So this shows, it's 11 o'clock at night. Cut me a break, right? So this shows the parameters, right? So there's all these different parameters here that can, and it says what the default is, right? So it will even tell you what the default, if you don't put anything, how the program will actually use this. Let's see. And so if you look at the top couple lines, let's see. So when it has these equal signs, so dtype. So if you look at load text, so this is the name of the function, right? So dtype equals this, comments equals number, delimiter equals none, converters equals none, skip rows equals 0. So those mean the equals and then whatever values behind it, that's the default value. So the only thing that load text has that isn't a default value is fname. So the function won't work unless you give it a file name, right? That's pretty important for the function to work. But everything else comes with a default value. Let's do, so when we did this before, numpy load text inflammation 01.csv, v, and then this is how we started this whole journey of this video. We did this, right? So when we did this, the file name is assigned by default to this first one, right? So we don't have to specify file name, because if we look at this, it's the first thing in the list. So it puts 2 and 2 together. It says, okay, this needs a value. And so the first thing is going to be the file name. And so the problem that we have is because since these things have defaults, what it does is it will try to put our comma to the second thing in the list, right? And that is the D type or data type, right? So our code produces an error message when we try to run it. When we call load text and we don't have the file name provided for the file name because it's the first type of the list, but we want the comma to be assigned to the delimiter, we do have to provide the delimiter part. Otherwise, it will try to assign it to D type or something like that. So generally, it's good. I think it's good practice to write these type of things in there because it makes it readable. Like if you give this code, even to yourself, I can't tell you how many times I had to pull code from something I did years ago, and I pull it up and I read it and I'm like, what the hell was I doing? Like, I don't know what any of this stuff means anymore. So it's good to have that for yourself too, in these functions. And kind of a, not a side, but how about limit, not limiter. There we go. And then last thing, this is an example provided by the software carpentry people, which is pretty good. So these two are the exact same function. And this goes with the idea of adding annotation to your code to be able to, for someone else to read it, right? So in this one, the top one is really poorly annotated. So define S, P, A equals 0 for V and P, A plus equals V. It just doesn't make sense unless you wrote it with specific things in mind. But if you read the second one, it says define standard deviation of a sample. The sample sum equals 0. So here they had A equals 0. You'd never guess what that was at. And then for the value in the sample sum must be greater than or positive or equal to the value. The sample mean equals sample sum divided by length, blah, blah. So this is just kind of showing you that you can code real dirty. And I'm not the best at it. I'm pretty good at, my problem isn't not using descriptive things. It's not using descriptive things but making them too similar to each other sometimes. And so it's good to have descriptive and different things, right? So yeah, just an example. So we finally made it through creating functions. Save your file is creating functions part 2 for that one too. But yeah, so we finally made it through. I hope you enjoyed the video and you kind of learned something. Functions are cool. They save you a lot of work. Like I said, if you've ever had to edit like a whole bunch of Excel spreadsheet cells or something like that, these things are invaluable. So with that, next we are going to do errors. I hope it's not as long. This last one, so I don't know, software carpentry, I love them to death. They put some good stuff together, but they said that last one was 30 minutes. I think I did like 5 videos on it and they were each about 30 minutes. So next we're gonna do errors and exceptions. So I'm hoping this one will be a bit shorter, and then we can move on. But I hope you're getting a feel for Python. If I'd be interested if you guys are someone that took R with me, what one you're liking better so far. If you like the R Studio and R combination, or if you like this Python notebooks and Python 3, if you find that one a little more intuitive, or if you don't even care. Yeah, let me know. It'd be interesting to hear what you guys think. So with that, I'm going to be done rambling. I'm at 20 minutes. So thanks for watching. Hit like, hit subscribe on YouTube, people. And let's get into some errors in the next video.